In question 4a part 1 we need to outline the essential features of a step-down transformer when in operation. Well, a step-down transformer has more turns on the input or primary coil than on the output or secondary coil. The coils are wrapped around an iron core and the input is an alternating current. In part 2 we need to describe two causes of energy losses in a transformer and go on to discuss how they may be reduced by suitable design and choice of materials. Well, the current in the coils of wire causes heating due to resistance. This can be minimised by using copper wires, as copper has a low resistivity. The wire should also be made as thick as possible, particularly on the higher current side of the transformer, as thicker wires have a lower resistance. The changing EMF in the iron core will produce eddy currents. These will heat the core and again lead to energy losses. Eddy currents are minimised by using a laminated core, with the laminations insulated from each other. This reduces the eddy currents and so reduces the heating effect. In B part 1 we need to find the power wasted in the internal circuits of a television when left in the standby mode, and we have a diagram showing us that there is 9 volts going to these circuits, passing a current of 300 milliamps. Well, power is current times potential difference, which is 300 milliamps, or 300 times 10 to the minus 3 amps times 9 volts, a power of 2.7 watts. In part 2 we're told the efficiency of the transformer is 0.90, and we need to show the current supplied by the 230 volt mains supply will be 13 milliamps. Well, 0.90 for the efficiency multiplied by the current and the voltage, the power going into the transformer, will equal the 2.7 watts coming out. Rearranging for current, we get this expression, which gives us 0.013 amps, which is 13 milliamps as required. In part 3 we're told that TV is left in standby for 80% of the time, and we need to find the amount of energy in joules wasted in 1 year through the use of the standby mode. We're given a year as being 3.15 times 10 to the 7 seconds. Well, the power is the work done over time taken, so the work done is the power times the time, which is the current times the potential difference times the time. 0.013 amps times the 230 volts for 80%, or 0.8 times the number of seconds in a year, gives us 7.6 times 10 to the 7 joules. In part 4 we need to show that the cost of this will be around £4 if electrical energy is charged at 20 pence per kilowatt hour. Well, the energy in kilowatt hours will be the energy in joules divided by 1000 to equate the kilo term, and by 60 for minutes and 60 for seconds to cope with the hours term. This gives us 21 kilowatt hours, so the cost will be the 21 kilowatt hours at 20 pence each, which is 420 pence, which is around £4 as required. In part C we need to discuss one advantage and one disadvantage of leaving a computer on standby when not in use. Well, clearly an advantage will be the saving valuable energy resources and therefore the saving cost. A disadvantage is the time wasted while the computer starts up.